All right, so our next lesson, we're just going to kind of progress forward. We're still working with our real numbers. This particular lesson, we're going to just talk about how to multiply real numbers and some of the properties we get from multiplying real numbers. This will get into a little bit more reason of why we change some of our double signs. In the last lesson, we were adding and subtracting, so hopefully this will give you a little bit more feel for why those things are true. Now, to help us with multiplying our positive and negative numbers, all right, we're going to use a very important property of real numbers, which is the commutative property. All right, the commutative property says that if we have a times b, that will equal to b times a, and you know that this is true. You've seen this a lot. So 3 times 2 is 6. All right, 2 times 3 is 6. 5 times 9 is 45. 9 times 5 is 45. And so what this is going to allow us to do is kind of move around and use the commutative property to group numbers in a way to help you get a visual representation of those numbers. Now, remember, when we do this, multiplication really is a shortcut for a long addition problem. It's a way of saying, okay, how many numbers do we have in each group? All right, we can multiply those, which is really just quick addition, and get a sum very quickly. All right, so when we think of a multiplication problem, what we're going to do is say the first number is telling us how many groups we have. All right, so 5 times 3, so we have 5 groups. And the second number is going to tell us how many are in each group. And this is going to be important because this is going to allow us to kind of look at what kind of numbers in the groups, which will help us then develop our rules for, all right, multiplying positive and negative numbers. Okay, so let's look at this example. All right, and once again, I'm going to use blue to indicate positive numbers and red to indicate negative numbers. Now, so if we look at this, all right, what this says first is that I have 2 groups. All right, so I have a group here and I have a group here. Now, this says then I have 3 in each group, and it's a positive 3. So I have 3 in this group, I have 3 in this group. Now, what you can see very quickly is all I have are positive numbers. I only have blue tick marks. So my result has to be positive. That's the only kind of numbers I have here. And in fact, I do have 3 in this group, 3 in this group, which gives me 6. Now notice, if we have 3 first, that says we have 3 groups. So we have a group here, we have a group here, and we have a group here. Now, how many are in each group? This amount, and it's a positive 2. So I have positive 2 here, positive 2 here, and a positive 2 here. All right, so you can see, in fact, I still have positive 6. So that commutative property is working. All right, so we have a positive times a positive, and we have a positive times a positive, and we end up with a positive number. All right, so there might be a pattern to this. All right, so let's look at another example here. All right, so we have 5 times 4. So this is the amount of groups. So we have 5 groups. So 1, 2, 3, 4, and 5. Now, in those groups, I have this amount. And once again, it's a positive 4. So I have 4 in this group, 4 in this group, 4 here, 4 here, and 4 here. And once again, what you can see very quickly is all I see are blue numbers. There are all blue numbers here, so my result has to be positive, and in fact it is positive 20, which many of you know already. All right, so you can see that. Okay, that works out really well. Now, if we look at this, this says we have 4 groups. So here's our 4 groups. Now, within those groups, we have 5 items, and those 5 items are positive. All right, so... All right, and once again, you can see that, yes, they're all positive numbers. I only have positive numbers. My result is positive. So once again, we do a positive times a positive times a positive, and we end up with a positive number. So now, that's our first rule. All right, that a positive number times a positive number results in a positive number. Now, the reality is, you've had this result since probably like the 2nd grade when you first started multiplying numbers. That's all you worked with, were positive numbers. So to you, this should seem like a natural consequence of the many things that you have seen already as you've worked with numbers. All right, so anytime you have a positive times a positive, you get a positive number. All right, so now let's look at what happens when we have a negative number. All right, so now, all right, so once again, we want this first number, all right, to represent the number of groups. So this says we have 2 groups. All right, so we have a first group here, and we have a second group here. Now, what is in this group? We have -3 in each group. So 1, 2, 3, 1, 2, 3. Now notice what happens. All I have are red numbers. All I have are negative numbers. And how many negative numbers do I have? 1, 2, 3, 4, 5, 6. I have negative 6 for my answer. Now what should not have changed is that you have known, once again, since probably like second grade, that 2 times 3 is 6. That's going to be the numeric result. So the only question is, okay, what kind of number do I get? All right, and so once again, we see a great visual here that all I have are 3 things here. And you can think of like pens and pencils, right? This says I have 2 groups of pens, all right, and 3 pens in each group. So I bought 2 packs with 3 pens in them. Well, I get 6 pens. If I had 2 packs of 3 pencils, I'd have 6 pencils. It's a different kind of object, but it's still 6 of those objects because I have the same amount of group and the same amount of things within that group. All right, so now let's look at this example. Now, so what we want to do here, we have a negative number first. So we're going to use that commutative property. And so what we're going to do is we're going to put the positive number first and the negative number second. So that positive number, all right, really helps us, all right, with our number of groups. So we have 3 groups. So 1, 2, 3. And so in those 3 groups, we have 4 objects. All right. So now, once again, all I see are red tick marks. So my result has to be a negative number. And then, like I said, you've always known that 3 times 4 is 12. That fact is not going to change. All right. So I can see visually, yes. All right. All I have are negative numbers. Okay. So now, what we have, all right, is a really good visualization of, okay, why a positive times a negative is a negative number. All right, and how about one more of these? All right, so negative 5 times 4. All right, so now, once again, we're just going to go ahead and rewrite this where the positive number is first, the negative number is second. So I have 4 groups. 1, 2, 3, 4. All right, and then I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. And once again, very quickly, you can see all I have are negative numbers. My result has to be negative number. If all I have are pens, I got to get pens in the end. All right, when I walk out of the store with my 4 packs of pens. All right, and how many pens would I have? I would have 20 pens. All right, so this is just once again a very easy way to sketch it out so you can see what kind of numbers you have to tell you what kind of result you have. And this actually gets into our second rule. All right, is that whether I have a positive times a negative, all right, or a negative times a positive, I end up with a negative number. Now, so to kind of piggyback on our lesson, our previous lesson, we had a problem kind of like this, right? Where we had maybe something like this. All right, and we talked about this conceptually. So now we've actually kind of gone through some pattern finding and say, oh, this really is a positive 1, all right? Really a positive 1, you just don't see the 1 mathematically, we don't write that a lot. But this is a positive times a negative, so then that's really why it's 6 times, or 6 minus 3. All right, and you can go the other way. So if I had this guy, this is really a negative times a positive, which we now know and is confirmed is a negative. So that just kind of confirms and gives you a little bit more hard evidence of why we changed those signs like we did yesterday. All right, now the last property is a negative times a negative, and this is a little bit harder sometimes to see why this is true. All right, so to help with this, we're going to do a little bit of pattern finding. All right, to see, all right, why it is as it should be. All right, so now, all right, so when we look at negative 2 times negative 3, all right, so we have this negative, we have this negative. So once again, the 2 times 3 part we know is going to be 6. All right, so 2 groups of 3 will be 6 each and every time. That's never going to change. But this issue is, okay, what happens when we have this negative times a negative? All right, and how does that affect us when we have a negative 2 groups of a negative 3 items? A little hard to represent, all right, maybe conceptually for some of you. So let's look at, all right, a little bit of a pattern here. So let's look at this guy. So let's look at what's happening here. So when I do 4 times negative 3, we get negative 12. Okay, we've discussed that property. When we do 3 times negative 3, I get negative 9. 2 times negative 3 is negative 6. 1 times negative 3 is negative 3. 0 times negative 3 is 0. Now, so what we can see is what is happening here. So I'm adding 3. I'm adding 3. I'm adding 3. I'm adding 3. So this pattern should continue, so I should add 3 here, and notice I would get a positive 3. A negative 1 times a negative 3 is a positive 3. Amazing. And then notice I would add 3 again to continue the pattern. This would give me 6. And we know that 2 times 3 is 6. So that means then that a negative times a negative would have to be a positive. And then we continue the pattern. We add 3 again, and that gives us to 9. We know 3 times 3 is 9, so that makes sense. But that then implies that a negative times a negative is, in fact, a positive number. All right. So now, that's one way of kind of looking at, oh, a negative times a negative is, in fact, a positive. You can look at it like, all right, this says, okay, a left, if you make a left and then a left, you're really going right again. All right, so you can think about it conceptually in terms of direction, all right, on a number line. All right, another way we can think about this is using our zero property here. And so let's kind of, where's my screen shade? There we go, and we'll kind of talk through this step by step. Okay, so we know that negative 1 times 0 is in fact 0. Now, we can rewrite 0 as negative 1 plus 1. All right, so we know that's true. So 0, okay, I got to get to 0, so negative 1 plus 1, all right, that's 0. Excellent. Now what we can do is use the distributive property. We're going to talk a little bit more about this in a little bit more detail later, but you've all seen this before. And so with the distributive property, I do a negative 1 times a negative 1 here, and then I would do a negative 1 times a positive 1 here. And I'm going to rewrite that using our distributive property. All right, so a negative 1 times a negative 1, and then we have a negative 1 times a positive 1. Now, here's what we know. We have developed this rule. We know that a negative times a positive is, in fact, a negative number. All right, so that product will be 1 times 1, which is 1. A negative times a positive is a negative number. All right, there it is. So that's negative 1. Now what we know is that this still has to all equal to 0. That's what we started with. So we have to use our zero property. Well, if this is negative 1, the only way to equal to 0 is whatever is right here must be 1. It has to be 1 to equal to 0. All right, and if that is true, all right, the only possible way for that to be true is if negative 1 times negative 1 is in fact a positive 1. All right, so there's a couple of developments to help you with our final rule, all right, which is a negative times a negative will in fact be a positive number. Now, once again, that gets into what we looked at yesterday, all right, or the day before with our other lesson when we had something like this. This is really a negative times a negative, which is why we changed that double sign to this. Okay, so real quick, I've got a few 6 example problems I want you to do right now. All right, so go ahead and pause the video, go through these and answer these 6 questions really quick. Flip me back on and let's see how you did. All right, so let's go through these real quick. All right, now, so what I would do is anytime I'm doing these problems, I'll always figure out my sign, my SIG into the number first, and then do the multiplication fact. So a negative times a positive is a negative. 3 times 3 is 9. Okay, moving down here, a positive times a positive is a positive. 5 times 2 is 10. A positive times a negative is a negative. 6 times 1 is 6. So there's a 2-part process anytime we're doing these problems. Always figure out your sign first. A negative times a negative is a positive. 3 times 5 is 15. A negative times a positive is a negative. 8 times 2 is 16. A positive times a positive is a positive. 2 times 7 is 14. All right, my friends. All right, that's all for now. Go ahead and answer the self-assessment questions in the Google form. All right, and then